Okay, we're going to talk about the calculations for those colligative properties. Remember we talked about adding a solute to a solution and it changes the boiling point. So lots of times when you do boiled pasta, you add salt to the water, and we're going to see how that changes the cooking water, the temperature for boiling point. So there's two ways to express concentration. We have two new ones. This is called molality and mole fraction. So these are two different ways that we can also express concentration. We did molarity before, but this one's called molality, and there's another one called mole fractions. So molality is a lowercase m, and it's how many moles of solute do you have in 1 kilogram of solvent. So before molarity was moles in 1 liter of solution. This is a little different. This is called molality. This is not used as commonly, but we do need it for colligative properties. So to make a 0.5 molal solution of sodium chloride, you're going to measure out 1 kilogram of water, and you're going to measure out a half a mole, which is 29.3 grams, because remember sodium chloride is 58 point something grams per mole. We need half of a mole. So then you measure that out, put it in your 1 kilogram of water, and stir it up. That's a 0.5 molal solution of sodium chloride. So we can also add like ethylene glycol to water to change the water boiling point and freezing point, and that's called antifreeze. So we can put 1.25 moles of ethylene glycol in 4 moles of water, and the total moles is 5.25 moles. The mole fraction then is ethylene glycol is 1.25 out of a total of 5.25, and this is called the mole fraction. And you can also do a mole fraction for water. So how would we do molality here? We're going to have 500 grams of water, and we want to make this molal, so we need to figure out how many moles we need of potassium iodide. So we have the mass of water, we have the molality, we have the molar mass from the periodic table, and then we can figure out grams. So we're going to do this process, mass, moles, grams. We have 0.5 kilograms of water, we have 0.06 moles of Ki in 1 mole, that's our molality, and we know the molar mass. That gives us the grams of Ki we need to put in that solution. So you can try this one for a molal solution. And a mole fraction is a different way of measuring concentration. It's a ratio of moles of solute to the total number of moles of solvent and solute together. So moles of the solute over the total moles in that container, moles of solute and of the solvent. So here's another example. We have 1.25 moles of Eg and 4 moles of water. And then we add them together to get the total. And we get 5.25 down there. And we have 1.25 of the Eg, 4 moles of the H2O, and that gives us mole fractions. These mole fractions always have to add up to 1.0. So that's how you can see if you did it correctly. So we always have to equal 1. Here's another one to try. And how are these related to molality? So we use molality to do this colligative property calculations. So the change in the freezing point, that's what this says, and the change in the boiling point are directly proportional to the molality. So that change in temperature from the regular temperature for freezing point is molality times a constant. So this constant has to be given to you. Here's constant. So if you had to do this problem, we'd have to give you that constant. You would not know that one yourself. So same for boiling point. There's a constant from a chart. The molality of your solution will give you the change in the boiling point from normal. So we'd have to give you the Kb for that. So the math's not too bad. The thing to remember though is we're not talking about the boiling point, we're talking about the change from its normal boiling point. So for water it's 100 degrees. If you had a change of 1.1 here, then you'd have a boiling point of 1.0, 101 point whatever. So this answer that you get here has to be added to the boiling point. So that's where people make mistakes. So this is showing, this is our normal phase diagram, and this is water. The red's water, pure all by itself. But if we add some solute, it changes where these things happen. So that's what we're talking about in colligative properties. So here's another example. We have ethylene glycol, 0.5 kilograms of water, and we're going to use that equation there to figure out the change in the freezing point, but we have to figure out the molality first. So we have that many moles, we have that many kilograms, do the division, that's our molality, then throw that into the molality section, find this KF off of the chart, and then we can do that math. So instead of freezing at 0, we're down lower. So this makes it a lower temperature before the water can freeze. That's the purpose of adding an antifreeze to water. We can try that with the glucose there, freezing point depression. And we can do boiling point changes, 1.5 mol NaCl. We find this number off a chart, the Kb. We put those two numbers together, multiply them, and we will get our answer. Oh, the other thing to remember is NaCl breaks into two pieces. So instead of having this molality here, remember we have to figure out particles. So this would be 3 mol in particles. So make sure you remember that part. And then do the math to find that change in boiling point. So instead of boiling at 100 degrees, this would boil at 101.54 because you add this change to the boiling point. So there's one you could try. Remember, NaCl is going to break into two pieces. So let's see how you do on this one. So you're probably going to have to stop me, freeze me, do the math, and figure out how much He is as a mole fraction, helium, and then pause me, and then here's the answer. So try that one. Next question. Freezing point depression caused by a given concentration of a non-volatile molecular solute, and then decide what you think. Okay, here we go. Depends on the solvent. Last. So this one you're going to have to pause me and do the math of this, and use those formulas I gave you, and then remember to change it from 0 and 100 as our normal boiling points and freezing points, and do that change. So you should get this if you do it correctly. So I hope you learned a little bit about doing colligative properties and changing boiling points and freezing points. I'll talk to you soon.